Hello, kiddos. Welcome to lesson 7 on page 61. You need to open up your book and follow along. We're going to be extending our understanding and applications of ratios to solve and to look at a little bit deeper some more story problems. So, our example 1 here is National Forest deer population. Is it in danger? Question mark. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest where they investigated, conservationists counted 117 deer in a 13 square mile area. And then a third set counted 216 deer in a 24 square mile plot of the forest. Do they need to be worried? Are the deer too spread out? Are there more in certain areas? What does it look like? Okay. One question I ask is, why does it matter if the deer population is not constant in certain areas? Could there be some reasons where the population is not constant, and does that really matter? Well, why would deer be in different areas? One answer could be that animals move to where the food is. Okay. So there might be more animals in one area than another area. So animals move to where the food is. That's one reason maybe it's not constant. Another reason could be that in one area there might be overpopulation. And when an area is overpopulated, what happens? Well, it might cause movement. And so those animals are going to move around. So there might be more animals in a certain area. Movement. Okay. And there are many reasons. I came up with 3. They're kind of all tied together, but maybe there are more animals in other areas because the land may not be suitable for the animals. Land may not be suitable for life. So are you going to have a lot of deer in that area if it's like rugged terrain and no food? No. Okay. So you might come up with some other reasons, but those are some that conservationists would look at and try to decide, are we okay? Are they too spread out? Is there more in one area, less in another area? Now, they want us to look at the population density of deer per square mile. So here's the deal. Notice what they say here. The population density per square mile. The population density depends on your square mile. So this is going to be your Y. Your square mile is going to be X. Your square miles. You can pick whatever square miles. And then your population, depending on how big or small that is, will be bigger or smaller. Okay. So we're going to talk about square miles. All right. And that would be like our X. Our Y would be the number of deer in that area. And they've given us that information. That's our Y. Okay. So just going from the reading, we had a 16 square mile. That was 144 deer. We had another area that they figured out was 13 square miles, and there was 117. And then the last one was 24 square miles, and they found there was 216 deer in that area. Well, now what we're going to do is find our K value, which now has a new name. We did call it before the unit rate, right? The unit rate, but now we're going to have it as a fraction. And we've seen this kind of before, but it's Y over X. So now what you're going to do is take 144 divided by 16. Do that quick in your calculator. 144 divided by 16. You should get 9. Now do 117 divided by 13. Again, your Y divided by your X. The number of deer divided by the number of square miles. And that's what they're saying, per square miles. Guess what? 9. Do it real quick. Do 216 divided by 24, and you should get 9. So do we have a constant of proportionality? It appears to be so. What does that mean? Well, the unit rate of deer per square mile is 9. That means there are 9 deer per every 1 square mile. Now, that ties into our constant of proportionality, our k, which we now call y over x. And all that equals 9 every single time. Okay? Now, what does the meaning of this constant proportionality mean in this? What does that 9 mean? What's the label for it? Well, that means there are 9 deer in every, and we don't really have to say it, but every 1 square mile. Every square mile, you should find 9 deer. Now, sometimes when they're moving around, you might find more, but on average, you'll find 9 there. Now, it says use the unit rate of deer per square mile, or that y divided by x, to determine how many deer there would be for 207 square miles. Disregard that bell. So we go back to that formula, y equals kx, which notice this. We want to find the k. There's the x, right? We know the k. Look at how that ties to that. K is equal to that. See that right there? See that right there? We'll see that more in the future. So we know the y, which is our number of deer, would equal 9 times how many square miles? That's our x, 207. Okay? You can actually do this one in your head. What's 9 times 2? 18. What's 9 times 7? 63. Check it in your calculator. It's correct. And what's the label for that? What does that mean? Well, what was the y standing for? Up here, it would be 1,863 deer. All right. Now we're going to use that unit rate to determine the number of square miles you would find 486 deer. So now notice this time we know the deer amount. We don't know the square miles. We know the y. We don't know the x. So you would set up an equation like this. 486 equals, well, I know that k value is 9 times, well, the x is the unknown. And here's the deal. 9 times something equals that. To find out, we divide by 9, divide by 9. Go to your calculator. Take 486 divided by 9. Plug that in, get that practice. And you would find that the answer is equal to, I hope you have it by now, 54. 54 equals x. And what does that mean? It's 54 miles squared, or square miles. Okay? That wraps up example number 1. What you're going to do is click into the example number 2 in the other video.